I'm going to go ahead and share out these files. So homework 10 should be shared out there in Canvas. So these will be out there for you. There is a homework 10.pdf there. Last semester, we ran into issues where the down or eduke.jmu.edu. So we had to have that homework 10.pdf in there. That was the description of homework 10. You can ignore that if everything is going well. I think we should be fine there. I've got two different tests and then one actual Java file for soccergame.java. So I'm going to go over the tests and actually create these tests for the parking lot and the tree planter portions here. So I'll go ahead and set those up in Eclipse too. That way you could get some more practice and see some more practice in setting that up as well. So I'm going to go ahead and share my screen now. Let's go ahead and share this screen. Turn off my email so I don't keep getting notifications. And kill this Excel sheet because we don't need that taking up space. Let's see if iTunes is ready to close yet. Nope, it's still downloading something. All right. So today's material is this UML diagram reference. So over here, we've got how to read a UML diagram. Again, the class name is going to be at the top here. So you'll have this piece at the top actually giving you the class name. You'll have the attribute here for the class or the attributes for the class, and then you'll have the method names here. A bunch of it in the form, the scope, so public, private, or static. Then your method name and your argument list and argument types for your method, and then your return type at the end after a colon. If you're looking at this here, you've got this credit card class here. This is also going to show the different relationships. If you have an association with something, or if you have an inheritance, something inherits properties from a class. You have dependency here. In here, there's an aggregation. What this means is that one owner can have multiple credit cards, and that's going to be the case. So we would allow in this company, one owner number could have several credit cards attached to their owner number. So they could have 2 or 3 credit cards with this company. That may be an actual scenario that some companies do. Other companies are going to offer just one card per owner. So this would be just a straight line here instead of this aggregation, which means that you've got multiple. It's a one to many over here. One owner to many credit cards. Some would just go one to one here. So if we take a look at the credit card class, it's got an annual percentage rate, APR. It's got a credit limit that you're going to have here. We're going to say this APR is 29%. This is a pretty horrible credit card. I would never recommend buying this credit card. They will be gouging you with your interest rates. This credit limit is also $2,000, so you can get multiple of these horrible $2,000 credit limit credit cards that are at basically 30% interest rate. Again, this is the bank of no return, so don't borrow with these people. Attributes that you're going to have here are including your card number, which is going to be a private attribute, your owner number, which is a private attribute, and the balance, which is a private attribute. The security pin here, you would not want to be public, so we'd want that actually to be a private attribute as well. So I think it's mislabeled in this particular diagram. Out there as public information. So similarly, you've got an owner with an owner number, name, and a social security number. This is all private information in the attributes as well. And then you've got this get name as the one public method here that we have available. Over here, we've got a constructor for the credit card. and I think there's actually two constructors. There's going to be what we call a default constructor, which will create an all nines owner number and all nines credit card number and a zero balance and security pin of 123. Then there is what we call an explicit constructor. This constructor is one where we're going to actually pass it a couple parameters. So we're going to pass this credit card, and we are not showing that in this particular UML, but you would want to pass this the card number and an owner number so that you're actually passing two attributes to that method. So you've got a card number and an owner number, and you're creating a card for an owner, and you're setting the balance to 0. And again, this security pin will be 123, just a default value there. And then we're going to have the user change their pin at some point with a change pin method. We don't show that method in here, but we have the method available in here. We'll have a adjust pin method available in here. I'm going to change this up this afternoon. I realized that I need an adjust pin to get the class coverage going correctly and showing correctly. So I will be changing that portion up so that that looks behaves properly. So let's go ahead and get this done. All right. And don't forget for tomorrow night that assessment is due at 11:59 p.m. So make sure you get that done as far as the audio good now. Let's see. Hopefully, yes, good. Okay. Let's see then. We've got this credit card example. So we set this class up, creditcard.java, credit card, and this is going to be a .java. We would go ahead and create that, but I've already done that. So I'm going to just load this piece in. This is just a copy and paste from this class out here. I'm just going to go ahead and do this so that I can show the pieces here. This is all those pieces, plus I added in this adjust pin method here so that I can adjust the pin, because what I wanted to do was be able to do some testing and create a JUnit test properly. Let's go ahead and save that. And actually, I'm going to go ahead and delete this so that I can go ahead and recreate this from scratch. All right, so let's go ahead, and we're going to go ahead and try and do some coverage testing with this and create a test for all of these methods to make sure that these methods are working properly. We're going to go over here and we're going to go new JUnit test case, and we're going to do a JUnit 4 test, and we're going to call this credit card test. I'm going to generate comments, and the class under test is going to be credit card, but let's go ahead and click here, and then we'll create and it's going to grab credit card class to be the one that we want to do our testing for. And we're going to go ahead and set up, this is a nice way, if you've already written stubs or some of the other things, you can set up I'm going to do a constructor test. I don't need to do a second test for the default, or explicit constructor because we're just going to do one constructor test. I'll do a balance test. I'm going to do a toString test and an equals test. Those are the tests I want to do because I think the other methods are going to get covered by those tests. So let's go ahead and hit finish, and this will create our piece here. It usually will ask if I want to do the associate and add the JUnit library to that. I've already done that once in this, so it won't necessarily do that again. So know that that's going to be the case. We'll go ahead and make sure that's all set up. And we're going to go ahead and write in these classes. Grab some materials here. Make sure I've got stuff I wanted to use here. Yes. Okay. So first test we're going to implement up here is the default test. So this test public void default test, and we're going to call that, and then we're going to go new credit card, and that should exercise our credit card. So if we do this and we hit the coverage piece here, it's going to run my tests. The tests are, a bunch of them are going to fail, and I'm going to get a bunch of red over here as far as what I've covered. I've covered this default constructor, and that's all I've covered so far in here is by creating a credit card. I've run this code here. So that's what that coverage is doing. We're covering the lines of code over here on the other side. We've got this one test that we run here, this default test that creates a new credit card. That's going to exercise this code right here and put it green. So we've tested that code. So now if I wanted to do a test credit card again here, I'm going to go ahead and set up a couple sample credit cards. Let's go ahead and do this. I've already done this on the side here, so I'm going to go ahead and just copy and paste this in so I don't have to be spending so much time doing all of this on the fly. This is going to create two new credit cards. Both of them are default credit cards, and then what I'm going to do over here is I'm going to test the equals method to see if these two are equal. Because everything in them should be equal. So let's go ahead and run this again. And then let's see what we're covering now. Are we covering anything else? Not yet, because some things are not really happy being run. Let's go ahead and run this way. Do this at org. And we want to do this as a non-static call. We want this as assert. So we can run things this way with the assert true. So let's go ahead and run this. All right, and this is going to run. We're going to get a little bit more. We've now started to test some of the equals piece here. So we've gotten equals where everything is equal. So all of these being have been tested. So now what we want to do is we want to see if we can create some other tests. I'm going to start testing the other constructor, and I'm going to create some more code here that will test the other constructor, this second constructor. We're going to create two credit cards that are explicitly created with the explicit constructor. We're going to send the card number as 123. That is not a valid card number, and then our user owner number 123. But we're going to just test these equals, and then we're going to test not equal by asserting a false assertion that CC2, this credit card here, is equal to this credit card here, CC credit card 4. And that's not going to be the case, so that's going to be a false. 3 here is going to equal 4, so we're going to get this to pass. I'm going to go ahead and run that real quick. Let's go ahead and see what we've got over here. We've got a little bit more. See, you can see this is green now with the explicit constructor here. So we've got that in a green state. We've got a few more lines in here where we've covered the equals, where the security is not out a little bit differently. Let's try doing this actually, 124, 124, and therefore we should get a couple other items that are a little bit different. And let's go ahead and see if getting more here. Looks like we've got a few more things, but nothing huge there. Okay, so this is going to be a constructor test, and that'll be the test for our constructor. We're going to come over here and we're going to test balance. And let's go ahead and call that as a call like this. We make some adjustments into the balance. We're going to set up, again, a CC1 credit card. We're going to do an adjust balance call to credit card 1, and it's going to be $20. The expected string we want to get when we run two string is this. We want to have a balance of $20. So this is how we're testing this particular piece. Then we're going to do another test in here, or we're going to make that test here by doing assert equals and say we want this expected value to equal the toString from this card. When we call this cc1.toString with the 20, it should have a balance of $20. Actually, this just have to be 123, 123, 123, and everything should be good there. Then we're going to adjust the balance of credit card 2, and then we're going to test that these two are equal to each other. So that should be good there. And assert false here, because CC2 equals CC1 is not the case, because our credit card 2 and our credit card 1 are not going to be the exact same thing, because we've got a credit card that is 999 and a credit card that is 123. So these two should be different. So that's going to be a false assertion. Then we're going to adjust the balance to something that we can't adjust it to. It's going to be over the credit limit, so it's not going to work, and it's going to say over the credit limit when we run this. And we're going to try and get the balance of this and then print the balance here just to validate that. So if I come into here and I run this now, always launch without asking. Let's go ahead and do that. So it's going to say here over the limit, and it's giving us the balance here of $20 as our balance, even though we tried to make the balance $2,100 because we're going to adjust the balance manually. Now, if we come over here after having run that, we've got green in our constructor, our default constructor, our get balance, our adjust balance, because we use that method as well. And all of these are green. So we've got green here. This is coverage. All these lines are covered. So if we had feedback from our auto lab grader, it would say we had covered 1, 2, 3, 4, 5 lines out of 5. So that's what it would say over here. 5 lines covered out of 5, 5 of 5, or missed 0 of 5. So for adjust balance, and it would say missed 0 of 1 for get balance. That's what those missed numbers are in AutoLab. So if that's been a mystery to you, this is what it's doing. It's going through our reference solution or your code, depending on if you're submitting tests that are running against your code or tests that are running against our reference code. If it's our reference code, then you're going to have the lines in here that it's going to say missed 0 of 1 or missed 1 of 1 if you did not cover that. Right now, adjust pin would be saying missed 1 of 1 here, because we did not cover this adjust pin method here. The other piece we've got is we now have run all the toString, 1, 2, 3, 4 lines of the toString, so missed 0 of 4 here. And over here, these yellow ones are this idea of branches. So we've covered this line of code, all 2 branches covered in this branch. And over here, it's telling us what's going on. 1 of 2 branches is missing. So we've tested that the owner number equals the owner number, but we have not tested the owner number not equaling the owner number and the card number equaling the card number. So that's one scenario we have not tested, and we'd want to test that to get those branches covered if we were trying to get full branch coverage. I'm not going to go ahead and do that because I think that's going to be a little bit extraneous and it's going to take quite a while to do. I'm going to go ahead and do a few more of the dot equals, and let's see if we can get rid of one more line at least in there. So let's go ahead and write one more test here, and then I'll move on to something else. Equals method. I'm going to bypass this toString because we've already tested the toString elsewhere, and we won't need that test at all. So I'm going to come into here, and we have the same credit card number, but we don't have the same PIN. our owner number here. So this should exercise some of those other pieces. Let's go ahead and run our coverage test, and then see. Yes, see, and so now we've been able to cover that branch and get that one changed. So if we are able to have a test there, now let's go ahead and do one other thing in this equals. If we do an adjust balance, CC2 adjust balance, and then we can do this, and let's see if we can test this, see if these two are equal to CC1 and CC2. We've just adjusted the balance of CC2, so this should hopefully get us a little more here. It's not going to, for some reason, it may be that we need to have both of these owner numbers the same, and then not have the other thing. So let's try this. Let's try creating a CC3 and 4. And this is where getting branches covered is a little bit tricky for trying to get things going. Let's go ahead and do this. We'll make these two numbers the same, and then we'll do adjust balance is the only thing that is the difference. And then we'll run that. Let's run here. And this should hopefully start to get us into the next thing. The balance is the only thing. So we've got those two the same. What we need to do is different, and then different balance too. So that's probably what it's wanting to do. If we can have that of here. Let's try this as, the other branch that it's trying to cover. And I think we're going to get closer to that. Or is it trying to do, oh, hold on. I'm not just here, so it's never going to get that. Let's do these as 1, 2, 3, and 999 and see if that was just me making the wrong data. All right, let's see that. True, so that's not going to actually work there because these are the same card, even though the balance is different. Oh, yes, because these are the only thing that's testing are the owner number here. Let's see. Oh, nope, 64 is what I need to do. All right, let's see if that works. All right. So there we go. We've changed that balance, and now we've got that balance done. The last thing we need to do now, I will be able to get full coverage here, and let's go ahead and do one more where we're going to go all of these the same, and then we're going to go, and the balance should be the same. Then we just need to adjust the pin here, and that pin is going to be the only thing that is different on 2. So then we're going to or 5 and 6. Let's go 5 and 6. And then we'll go 6 is the one we adjust. And then we want to insert false here, 5 and 6. Let's see if we can get this. Run that. And bingo, there we go. We've got all of our method here for the equals. So this is how you do full coverage testing. It's this idea of incrementing little bits and changing little bits between these things and understanding what are all the branches of your code that are being run here. So for instance, we know we have this and that. So we've got to have the positive where they're equal, and then not equal, equal and not equal, equal and not equal. So these are the different and conditions, and these are the branches that it's talking about. If there's an and statement, it has to be true or false of that statement. So these are the types of things you want to be able to do. Now we've got this fully covered class and fully covered test. So this is 100% coverage here. If we now we have 100% coverage. If we ran this through an auto lab, it would be giving us 100% coverage. So that's fully covering a class and testing a class. I will make this credit card test.java available on the website as well. I had not done that yet. This is the first time I had thought to really do this particular test. I think it's going to be a good one, hopefully, that I can keep for future semesters, because I think it's a helpful one to get you guys a good example of running through testing here and testing coverage. All right, so let's go ahead and put this down, and then let's go ahead and take a look at some of the homework, 10.1 through 10.3. We'll take a look at some of those pieces, and then I'll have office hours afterwards for those who might have some questions. All right, so 10.1, 10.3 are working with some of these point and rectangle classes. There's also a polygon class that we're going to be using. So this is trying to use other classes. Again, this point has an X and a Y. Make sure you look at all of the different UML diagrams here as you look and understand these things before you start the homework. You should go through these 2 or 3 classes and have a good understanding of what they're doing. Excuse me. All right. So for 10.1, we're talking about a parking lot. So what we want to do is understand the problem first. Major event happening at the fairgrounds, and cars are lining up from everywhere. Unfortunately, we don't have a neatly designed paved parking lot yet. We got a couple grassy fields been roped off. This is where you come into the story. We need a program to help vehicles find a parking space when they arrive. So we need to define a class parking lot, and so that's going to be the name of the Java class. And then what that class needs to do is it needs to run a method called search, and this search method is going to take a parameter of a rectangle array, which is the lot, and then it's going to have a rectangle that is the car. So there's going to be a car and a lot. There's going to be 2 rectangle objects, a rectangle array object of a lot with multiple spaces in the lot, which are all rectangles, and then 1 rectangle, which will be the car. So we're going to try and park the car into one of the spaces in the lot. So, for example, if the space is 10 by 10 at location 0, 0, so this would be a 10 by 10 space here at position 0, 0, we're calling this bottom corner. And the car is a 6 by 6 car. This is 6 by 6. This is a square car, so it's going to be a weird car, but we're just going to assume this so that we have the ability to make sure where this should be from a centering standpoint. And this square is going to be the easiest one to understand the centering aspect. So when we're parking these cars in the space, the car needs to be centered within the space. So what that means is in this 10 by 10 space, if we've got a 6 by 6 car, we need to have 2 feet on each side of the car. So we've got 2 feet in front. So this is 1, 2, 1, 2. So that's 2, 2 is the coordinate where we're parking or planting this rectangle. So the X and the Y here for the car would be 2, 2. So this would be updating the car's location, or the X and the Y, to 2, 2. And this is a 6 by 6 car, 6 wide and 6 high. So these are the attributes of the car rectangle. The rectangle that is the lot space, lot sub 0, let's say here, for instance, would have 0, 0 as the location and 10, 10 as the width and height. So that's what we've got there. So that's how we're going to be parking these cars. We're going to be looking at the spaces, and then we're going to be putting the car in and seeing if we can put the car into that space. What we need to return at the end is how many square feet are left over. And if we put this, again, 10 by 10 space with a 6 by 6 car in it, we have 64 square feet left over. So that's how that is being calculated there. And yes, you should always use the bottom left corner. Let's go to assume that space that this starts in, we're going to assume we need to go how many ever over and how many ever up from that space. So this one could be 0, 0. This also could be maybe 2, 2. So if you are starting at a different space, then you need to adjust that accordingly to make sure that whatever X, Y this space is located in is going to work properly. So let me go ahead and show you. I will share from my iPad here. A little bit more so we can kind of go over and see a little bit better what the overall is. So I've got this space here. So this is the parking lot. And I'm going to go ahead and go here. I've got a 4, 5, 6, 6 space here. And then I've got that would be the first space. Let's see if we can create another one that we're going to call at 8 by 8 space. So this is a 6 by 6 space, 8 by 8 space, and then let's do a 10 by 10, this same 10 by 10 space. I think it's 10 by 10. Hopefully I drew it. We'll call this 10 by 10 if it's not. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 10. So that's 11, 12 by 4, 5, 6, 7, 8, 10, 11, 12 by 11. Let's make this 12 by 12 just to make it easier here. Make it even 12 by 12. All right, 12 by 12. So these might be our full spaces here that we're working with. So we have a 6 by 6, an 8 by 8, and a 12 by 12. So we've got these 3 spaces we're working in here. And we want to park, let's say, a 2 by 2 car. So if we've got a 2 by 2 car here, this is where we're going to park it in here. Over here, we're going to try and center it over here as a 2 by 2. And inside of here, we're going to center it over here as a 2 by 2 space in the very center of things. So these are the types of things we need to do. We need to be able to figure out what this is here and what space this over here is. So we're going to want to figure out these coordinates of where we're parking this. So in here, it's if we start at 0, 0 in the inside of the space. So this is going to be relative to the space. So you're always going to start this 0, 0 or where you're going to park the car from this 0, 0 of your actual space. So this will be 0, 0. This will be 0, 0. This will be 0, 0 relative to the space. So we'll do this as a relative to the space kind of calculation. So this one's going to be at 2, 2. This one's going to be at 1, 2, 3, 1, 2, 3. So you got 3 here. So we'll be at 1, 2, 3, 4, 5, 5 there. So that's going to center at 6, 7. So you're starting at 6, 7 over there. So you're getting it evenly in the center of the space. So this is the kind of thing you're going to want to be able to do. So you've got this 2 by 2 car. Actually, this will, so we've got the 2 by 2 car in here, and we're going to basically do an algorithm to figure out what the difference in there is, and then what this actual space here that's left over is, so that we calculate this space. There's some degree of math involved in here. For those of you who aren't math oriented, I will probably try and give you a little bit more of the algorithm around this. This is what this is also for, to kind of give you an idea of the coordinate space that you're working with and how to figure those pieces out. So this will be there. Let me go ahead and I'm going to share this image, and I will. And then I will go ahead and make sure I make this available on the this probably is a little bit easier. So this is the parking lot problem. So let's go shift back and I will share now. Mute. Okay. What I want to share now is I want to share my screen back here, screen one. And let's come over to here. Oh, let's keep that recorder. Share screen one. Yes. All right. So this is the screen I want to share. We're back here. We're going to go ahead and I'm going to go ahead and create a project in Eclipse for this. Let's go. Yeah. iPad. I don't want to connect to that right now. Let's go up here. We'll create homework 10.1. Let's close this project. We don't have to deal with this. Let's go. Actually, I think I want to open this homework 10.1. That's probably the one I want to work with here. Yes. Okay. I have a default package here. Is this just a, yeah. Okay, so this one in here has basically the steps that we want to take to create the search. This is the algorithm that we're going to want to run to get through this piece. And then here are some tests that I've created. And I think these are the tests that I created inside of Canvas. So let's make sure that's the case. I'm going to come out here to the files and let's take a look at parking lot tests. So in order to test my parking lot here, see, I want a 10 by 10, 12 by 12, and a 14 by 14, and I've got a 6 by 6 car. All right, let's see. And we've got, yes, these are all the same. So this is what we are testing over here. So I've set up a first space as to where this one will be parked. So this will be parked in the first space. We've got three spaces, a 10 by 10, a 12 by 12, and a 14 by 14 in this case. So we'll actually be able to park this car. Actually, I'm going to go ahead and change to the same number. Now let's keep this example as is. So we've got a car that's 6 by 6, and we're going to have this 10 by 10 space, a 12 by 12 space, and a 14 by 14. So easily we can tell by examination that this is going to, the car is going to fit into any of these three spaces. But we're going to want it to park it in the first space. So the specifications say that we want to park it in the first space available. So we're going to go ahead and try and use the first space available by going in here. And this is going to equal the first space. And we're going to have 64 square feet left over. And we get that by taking the 10 minus the 6. So we've got the 4, and then we've got another 4. And we're going to get that 4 all the way around all the pieces. So going back to our diagram, we'd have this 64 square feet of space left after we park the car. So that is going to get calculated over here in our calculations. So, and we're going to get the parked car equals car.getX of 2 and car.getY should equal 2. So we're going to assert 2 that the location should be 2 parked. And that when we get X of 2 and the get Y of 2. So that's how we're testing where it is and what it's going to be. So this test is 2 assertions. It's using one to make sure that the equals here is done where we're equaling the 64 square feet remaining, because that's the return from this piece here, is to figure out what is the return square footage. That int that we're returning is the square footage that remains. And so we're going to do that as our first test. But not only do we need that, we need to make sure it's parked at 2 as well, that the location is 2. So in order to test that, we're going to do a second assertion here that the location of the X and the Y of this car are now at 2 instead of 0. All right. So we've got these pieces. So once we run this and get this working, if we run this test, probably a configuration here. So let's go ahead and set up a run configuration for this. We're going to go, this should just actually work for me. Oh, I want to set up one for this. There, because I have a main here. Okay, so if I run this, expected 64, but was 0. And so that's going to be the case because all I'm returning from this is a 0. So it's not going to return anything meaningful when I set up my car and run this again. Search against this search here I ran, and I'm getting no results back because I've got a 0 back here and my location is at 0, 0. So, and I want to make sure my parking location is 2, 2, but I'm resetting it to 0, 0 here. So in case it happened to not get set, it gets reset over here because I want to make sure that this is at 2, 2 inside of here, and then I'm not remaining here at 2, 2 over here. So this is the test that I can, a test. You may want to set up other tests where you're setting up other lots and other setups. Let's go ahead and I'm going to go ahead and write one more test in here. And let's go in here and we'll go, this time we'll go ahead and do the lot that we just created. So let's see. Second, let's go third space here. And we'll do that test because I know should only go into the third space. So we're going to go ahead and set up this other lot that I just set up in the thing here. We'll go 6 by 6 lot. And we'll go our space, we'll go an 8 by 8 space. 8 by 8, and we'll go a 12 by 12. And it should park this 6 by 6. Let's do a 6 by 6 car. And yes, the 6 by 6 car should only be able to fit into that third space. So we're going to bypass that second space. What's going to happen is this first space is going to be the same size. So it should reject. This only has 2 feet on each side instead of the 4 feet that we want in the overall. So with this here, we need to have all around, where is the specification? 2 feet of space around each one. So this one might actually fit into here. Let's actually give this a 7 by 7 so that we've got this not fitting into here either. And we'll be sure that this does not fit because we only got 1 foot on each side. And then this 12 by 12 will be where it should wind up. So we are going to, in here, conjecture that that is where that should be. And we would want to kind of figure out what the space of it is that is left over. Let's go ahead and here, we'll go ahead and let's go ahead and set this up as a 10 by 10 again, just so we can easily do the 64 again here. This will be the third space. And we're going to do this lot and car. And this time we have to set up lot 2 and car. We can keep the same car. Let's just actually not even do that. And we'll go car and my lot 2. And then we're going to go here equals car.getX. And that again should be equal to 2 by 2 because we're going to be putting it into the 10 by 10. And that's 10 space there. And then we're going to say location should be 2, 2 and parked. So this should work this time again. Let's see, where do we go? Parked 2. Let's go ahead and call that parked 2. Boolean. Yes, okay, so right, we've got everything there. Let's see if we have problems. So if we run this, we should actually be able to run it, but nothing's going to happen because again, we're still doing our 0 there. So this would be a second test that you could run in here to make sure that the location should be 2, 2. Well, third tier. Test, and those are the tests that we're running inside of there. we've got everything running at the right spot. All right, so that is the the first homework, 10.1. Let's go into here and we'll look at the student version of 10.2. So that we're looking at the tree planter, and in here, we want to do this. And so for this one, the files section, I've given you a little bit more tree planter test here. Okay, so in here, what I'm actually done is I'm going to actually run through this here with the distance here. I won't leave that out too long because I don't want you to have that one as readily available. I will go ahead and put together a description document that gives you all descriptions for all three of those pieces so that you'll have those available. So let's understand the problem that we want to solve here for the tree planter too. So let's go back out here to the specifications. For the tree planter, it's Arbor Day, and we want to plant trees. We've been hired by Parks and Rec to analyze the current layout of trees and recommend where the next trees should be planted. We want a tree planter class, and we're going to have points where we're planting trees. So we've got this idea of a yard or a space where we're planting trees in this yard, and we're going to try and plant the next place in the yard to plant the tree. So what we're going to have is this yard is a particular size, and we want to be able to say where in the coordinates x, y that we plant the tree. So in order, computes the distance from here to other trees and returns a total sum. So what we're trying to do is plant it the farthest away from one tree. So when we plant a tree, we want to plant the next tree as far away as we can from the other tree. So we're going to try and find the most optimal farthest distance from that tree. So in order to do this distance method, or this distance piece here, we're going to compute the distance from here, this current point, to all the other trees in the yard, or all the other trees, because we're going to have an array of trees. So let's take a look at this from a, man, I keep hitting that mute. Let's see, share content. Let's share my iPad again so I can draw this one up. All right, connecting. So for this one, we've got planner. And we're going to take a yard here. Let's just set up this yard here. We've got this yard, and maybe we have a tree here at 1, 2, 3, 2, 3, 2. So we've got a tree here at 3, 2. We've got actually that's going to be 4, 2. So we've got a tree at 4, 2. Got a tree at 8, 1. And we've got a tree at 1, 2. Two, 6, let's say. So those are our three trees we've got. So what if we're looking at the point here that is 3, 3? What if here is 3, 3? So we're going to want to compute the distance between each of these trees and here. So that's what we're trying to do with that piece, that the distance method, is we're going to try and figure out how much distance, xy distance here. So we're going to use our Pythagorean theorem to get this distance here between these two. So that's basically trying to figure out the c squared equals a squared plus b squared, that Pythagorean. So we're going to run C. So C over here should be C will equal the square root of a squared plus b squared. So what we're going to want to do here is to take that and that Pythagorean theorem against this piece here. So that's the piece that we're doing. Then the next piece we're trying to do is find the optimal location for this new tree. If we're trying to put in a new tree, where would we put it in? It's probably going to wind up being somewhere over here, so that it's farthest away from all three of these other trees, and that would share this out, save this, and I have that saved as well into my photos, and then again, I'll post this as well. So that's the gist of what we're trying to do there. You go ahead and go back to the specification for the soccer game. I just want to get all of these understood first before I go into any more code, so that all the explanations are available here. So this one here, we're developing a video game for here, something like EA Sports FIFA Soccer. So we're going to have this field, and we're going to have a rectangle that is the field. We're working with this field here that is in scale going to be a 12,000 wide by 8,000 tall field. So this is our field for the soccer game. And this one is going to basically have us have the 12,000 by 8,000 field, and from 0, 0, so this corner over here is 0, 0, to 12,000, 8,000. That's my XY coordinates for over here at this top right corner. Top lower left corner 0, 0, top right corner 12,000, 8,000. So what we're going to want to do is write an inbounds piece to kind of determine if any point of this ball, and the ball is going to be a polygon. So we're going to have, let's say, a hex here that we run into here, or actually let's do an octagon here just to, octagon here. So we've got 8 points on this ball. So we'll have any of these ball points here. We need to make sure that all the ball is inbounds. So for instance, if our ball is here, that is inbounds. And so we are still inbounds here because we have a portion of the ball that is inbounds. Even if 1 point of the ball is inbounds, we are fine. So for instance, if we have a scenario where the ball only has one of its points, let's draw this. So this is going to be a weird looking ball in this case, but what if this 1 point here was in contact? All we need is that 1 point in contact with the bounds in order for it to be inbounds. So this ball would also be inbounds. So what we're checking to make sure is that any point on this polygon here, any of the points here, 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 or here, if we've got this five-sided polygon, then we've got 1 point here out of the 5 that is inbounds. So we're going to want to loop through all the points in the polygon and make sure. So we've got n points here, n number of points, and then we're going to say, are either of any of the x or y for those points, any of these points inside the bounds. If any of the points is inside the bounds, then the ball is inbounds, and we want to return true. Otherwise, we're going to keep going until we return, and we'll return false if we don't have any of the points inside the bounds. So if we had this ball, for instance, out here, then none of these points would be inside. All of them are outside the bounds. So this one would be false. This one over here would be true, and return a true since 1 point out of that is in there. Then the other thing we're going to be doing is passing a ball from one player to the so and it's going to keep moving in the XY direction, the specified amount at a time until it reaches the player or goes out of bounds. So what we're going to want to do here is if we've got player one located over here, and then we've got an XY of 1, 2, we're going to keep going 1, 2, all the way up, 1 over, 2 up, rise over run, 1 over, 2 up, 1 over, 2 up. We're going to keep heading in the same trajectory, 1 over, 2 up, 1 over, 2 up, until we either hit out of bounds or we hit our second player. So what if our second player was over here at P2? If we hit the other player by their coordinates anywhere, then it is a successful pass, and we would say true, or if we hit this player with the pass. Otherwise, if we don't hit the player and we go out of bounds, then we would want to say false if we did not have this player here and we had only empty space. So that trajectory here would get us to false if we did not have this player here. So that's the idea behind the other one. We have this one available as well. All right, so that's the gist of what we're trying to do there. We'll try and share content now, and I'm going to share screen one. Back to my screen one here, and share just that. All right. So back here, that's what we're doing with the pass and the inbounds. I've created, again, a inside of Canvas here, there is a soccergame.java file here. This has given you a starter for main, for testing in main. Wanted to show you another way to test. So if we've got a polygon that is the ball, and we've got, here's how you create a ball by adding points to the ball. And these are the points that are going to set up the ball, and then the location of the ball. That's how you would set that up. And you want to be able to move these things and use this translate method to do some of the movement there. I'll go ahead and put together another piece that describes how to do that as well. Over here, there's a tree planter test here that gives you how to test the trees and set up testing the optimize method as well. So giving you an idea of how to set up the optimization of that and how to do the planting of that. I'm going to go ahead and leave those in there, and then I will also, like I said, I've created a file that is the homework 10 description. I'm going to go ahead and upload that into here as well. So let me upload that item here from my desktop. Desktop here, and I've got homework 10 description. So this is the description of that. You can go ahead and download that and kind of check out those pieces as well, and then figure out how to get those. Again, I will try and make those diagrams available as well once I get them downloaded from my iPad. So that's class. If you guys have any questions, you can stick around for office hours. I'll be here for probably another half hour or so if folks have questions. If not, I'll probably be getting back to some other things that I need to get done for my other job on the other side of campus. But again, I'll stick around for a little bit. If you have any questions, feel free to put them up in the chat, or feel free to turn on your audio if you want to chat from that perspective. But class is officially over now, and you're welcome to stick around for office hours.